Hey everybody, Tom Cherry Holmes here with the FujiNet project, and I'm bringing you a status report as of May 31st, showing you updates on the end device, the end utilities, which can be used alongside or with the end device, and more. To start off with, we've been doing over the last 10 days a number of optimization to the end device handler with the intention of making it smaller in memory. Little bit by little bit, we are taking and optimizing instructions. You can see some of the old instructions here versus newer instructions here. Trying to utilize bits of self-modifiable code to decrease code space wherever possible. Trying to do away with unneeded instructions. Just trying to squeeze things down, get rid of the error calls for right now whenever we're coming up, that sort of thing. With the understanding that basically we're trying to take and squeeze everything down as much as possibly can. Because the goal is really to try and get this down into the space between the disk utility package and the resident part of the DUP that gets loaded via the FMS. There's about a 528 byte window in between that we might be able to squeeze into. Maybe, maybe not. Time will definitely tell. We also have to figure out where to put buffers and the like as well. But that is a goal, and it's a damned good one. We may not get there, but we may get close, and therefore may be able to squeeze and get more back of your precious memory. So, in addition to the NDEV functionality, we've also been working on a series of complementary tools that will be packaged along with the rest of the FNC tools. Recall that the FNC tools are what we call the FujiNet Commandline tool. And these can be run either on a command line DOS, such as Sparta DOS or DOS XL or OSA Plus, or they can be run in DOS 2.0 or MyDOS. If you run it in a DOS that does not support command line parameters, it will switch to interactive mode and ask you for the parameters before actually doing the command. So it's very compatible in that way. And one of the things that we've been adding here are additions to the F commands, which do global FujiNet control for things like mounting and unmounting disk images, setting network parameters, creating new disk images, resetting the FujiNet, etc. But also the end commands, which either alter state of the end device or allow you to do end device features without having to load and keep resident the end device handler and CIO. There are situations where this is actually desirable. One of them is you need the MEMLO, because you need to be able to use as much memory as you possibly can. You only need a network feature for a few moments, so you use it and then it's just gone. The program's gone and you're done with it. So in that respect, we've added, in addition to NCD, which changes the network directory or network prefix for an end device, in PWD, which shows you what the prefix for the directory is currently set to. We also have Inder, which allows you to do a directory of an end device without having the end device present. And we have InCopy, which allows you to do copy files to and from an end device to a D device or any other CIO device for that matter, without the NDEV or end device needing to be present. Looking at some of these utilities, for example, we can see Inder is a good example of how to communicate with FujiNet without needing to use the end device. Essentially what you're doing is you are setting up a device control block that's used by the SIO routines in the operating system, giving it the appropriate parameters, passing it a buffer as need be, as well as a length as need be, and then calling SIOV, which in this case is basically just a JSR to E459 operating system, and dealing with any errors that might actually take place. For directory, we need open, we need close, and we need to be able to read each directory entry as it comes down the pipe here. We also need status to tell us whether or not we still have bytes that we need to fetch. And the reason that we need this is because when we are communicating directly with the SIO and a device at the SIO level, we need to know exactly how many bytes we are going to transfer. Doesn't matter which direction, but we need to know how many bytes we're going to transfer before we actually do the transfer. And the status command here will actually give us that by giving us the number of bytes that we need to transfer in either direction as the first 2 bytes of the status request that gets sent back. And for convenience sake, Atari has provided us 4 bytes in memory that we can take and store this and retrieve it later. This is dvstat, which corresponds to decimal location 746 to 79. So we go forward, and not much happening here. We grab our command line parameters, and if we're in DOS2, we show basically an interactive prompt. One of the interesting things that we actually do here, if you look closely enough, is I'm actually sidestepping. In this case, CC65 tries to be helpful by splitting up the individual, what it thinks might be individual command line arguments by spaces, much like it does in standard C. However, in our case, that actually can get in our way because some of the file names that we are dealing with have spaces, and we can't easily take and put quotes around them because we don't have an underlying shell that is blobbing together command line arguments and putting them into individual parcels to send back to an exec call of some sort. So we have to basically take the argument buffer that we have here that CC65 has helpfully taken and split up for us, put it all back together again as one string, and then deal with it. In our case, we have a few more conveniences as well. If you don't set a device path, say N:, as a path to be entered here, then it will go ahead and put that in there for us. We get a status. We then take and keep looping through and grab the directory, reading each bits and pieces into our buffer, printing the results as need be. Similarly, for things like InCopy, we have the InCopy command, which give us the ability to do file copies to and from different devices. Now I'm going to take and tighten this up a little bit more and allow more possible devices to copy to and from. But again, this is a good example of how to take and communicate with FujiNet directly without needing the end device. And as you can see, it's not much different from communicating on the CIO level. The only real functional difference is that you need to know how much data that you are transferring before you actually call SIOV. And the status command is very helpful in determining that information. InCopy is rather interesting because we have to determine which branch of code to run based on what we're copying from and to. Because if we're copying from an already existing CIO device, such as the D device here, then we need to use the CIO routines to actually take and do our copy. Whereas if we're copying to the end device, then we need to use SIO directly. So all of this is in here. This is a very good way to look to see how to take and handle these discrepancies and to talk directly to the FujiNet without needing to carry around NDiv all the time. And because of this, we have a utility here so that if you don't want to run NDiv or you don't need it all the time, you still have the option to be able to copy to and from various locations. Now, interestingly enough, if you look close enough at the code, you'll actually see that it's actually taking and getting the data and spitting it back out as quickly as it can. It's not sending the data in blocks. It's not buffering it all up. It's grabbing all the data as much as it can to put in the buffer and then writing that buffer directly back out through SIO. And if we actually look at this call to NWrite, we will actually see that it's defined in SIO here, and we're literally just taking that whole buffer, either read or write, and we're shoving it back out as is. What this essentially means is that on the firmware side of things, such as with network protocol TNFS, for example, we have to take extra care because we're going to either be needing to send back a completely huge chunk of data in the case of a read, or we're having to take and grab a big chunk of data in the case of a write, and we need to break up that big buffer into individual blocks that are nice bite-sized blocks that the TNFS can handle. And for that, we actually have a payload size that defines what this actually is, which in this case, payload size is actually 512 bytes approximately. So, with the overhead here, we're looking at just over 500 max bytes that we can send to TNFS at a time. And we're doing this because the reason we're doing this is literally because, again, recall that TNFS is a UDP protocol. It's a UDP protocol, and that means that we need to be careful not to send packets too large. Otherwise, the router will fragment them. So blocking them here and breaking them up into bite-sized chunks at the ESP will help prevent fragmentation from happening and making sure that the data gets to the other side reliably. So we take that, handle all the blocking here ourselves for read and for write. And all of this is abstracted from the Atari, so all the Atari has to think is, well, I want to send this big buffer over. It's going to have an interesting side effect here, which I call the long-ass beep, which you will actually experience here. There's been a lot of work also on the FTP device as well. Namely, we're no longer using hard-coded delays for things like expect processing. We're trying to wait for data to come in on the control channel as available and up to a certain timeout, and also with data stream processing as well. We are essentially trying to wait for data to come in and to ensure that data comes in so that when the Atari actually does a status, we don't just come back with 0 and say, oh, that's the end of the file. So this increases the reliability of FTP rather considerably as well. So with that, I guess we can go ahead and start going on to demos. I'll go ahead and bring up the video capture device, which is my Atari. We shall boot into the system here. Now, I'm actually going to remove the monitor from all of this real quick so that we don't hear it. I think actually, give me just a moment here. I apologize. I do apologize. They can make a slight change. That doesn't bother us going forward. Recording here, and I need to turn listen. I didn't realize that that was deal. Apologies for that. Technical. There we go. So now, for the first part of this demonstration, we're actually going to run the N tools from inside of DOS 2.5. I've already copied them over from that second disk to the first disk here, but I'm going to keep it in drive 2 for later. And for this next bit here, we're actually going to take and bring up the monitor window a bit more. And here we have our DOS 2.5 window. I've got some chroma noise on my... A little bit of chroma noise. I mean, literally, this cable was too close. All right, there we go. So, if we look on our disk directory here, we'll find that we have our N utilities here, along with a couple of F utilities right here, ready to go. For this first bit, we'll actually do a network directory from FTP, and this works just as you were doing a directory using the N device. So we'll use the NCD tool. The NCD tool works both with the N utilities and with the N device, because it's talking to the same thing in the end. The ESP is keeping track of a directory prefix, and it's prefixing all of this onto the paths that you send back through SIO. And all of this is persisted at the ESP. So if we, for example, set a prefix here, and then do a network directory, and again, you'll see that because I'm running this inside of DOS 2, it's going ahead and presenting me with a menu here that I can deal with. And I won't put anything on the end of it here. I'm just going to go ahead and hit return. We can see the FTP request happening right here, and we see the results coming back just fine. We can go a bit further, and since we can keep adding to the directory prefix, we really can just keep adding. Stuff, collections, home CD, homes 2, Atari archives, and we'll go to Antic files. I've been going to this directory a lot. I have it memorized, but see, there we go. And we can just keep going. So there is our wonderful directory for that particular chunk right there. We could, of course, also take and add that to the prefix. Now, because this is a directory, we need to make sure that we put the slash on the end so that it treats that as a directory file. So if we go ahead and do the look, we can go ahead and run Inder again. And because I've set the prefix, I can hit enter and it will go right back to. There we go. We can subsequently go ahead and, for example, not use that. Copy only works if you have N device loaded, but since we don't, we need to use NCOPY. And I know there's a particular file in here called frog execute. We'll copy it over. And you're about to hear this literally be bounced across as fast as possible. And because we don't have to take and break this up into individual sectors like we do with disks, we can ask SIO to take and just send it all over in a, in giant chunks. In this case, InCopy positions itself in memory so that basically it uses a 16K chunk of RAM for buffer. So it will transfer up to 16,384 bytes at a time. If we see it grabbing, we go. And there you heard a little bit of the long ass beep there. It literally took and bounced that over the end device SIO here, and if we look, we can see there's frog execute, and if we go ahead and load it, we actually see it came over. It's fine. Now that's from N to D. We can just as easily go the other direction as well. Now I'm going to go ahead and we have frog right here. I'm going to go ahead and load NCD again to set a network prefix a little bit differently. We're going to set a network prefix for drive 2. For network drive 2, we want to set a prefix for a TNFS server. And within a few moments, we see that that's the case. Now, I need to make absolutely sure that TNFS is here. Yep. This is a TNFS server that's running over here on my test machine. There we go. And now, if I actually take and load InCopy again, we're going to take and copy from the disk drive. We're going to copy from go the other direction. I'm going to copy it to N2. Now notice, in contrast to the read, the write is pretty silent. But you can see it transferred it over nice and nifty, and with relatively large packets. If you look close enough, we're actually transferring the 400 byte, 380 byte chunk. I actually brought that down to test a little bit, but shipping will actually transfer that in 500 and some odd. So you can see that's actually happening. And actually, if we go ahead, for example, we could copy it back, but it's there, and it copied it over to that TNFS server, ready to go. And not only can we do that, but you can also even do end-to-end copies as well. End-to-end actually does work. So let's say right now recall that you have N1 over on an FTP server and N2 over on a TNFS server. Well, I can just as easily, with either the end device or with NCOPY, do this. And believe it or not, this actually needs its own little chunk of code, specifically because we're doing this entirely over SIO without involving CIO in any way or fashion, especially for this code path, because we're not talking to any CIO device. And there we go. So now we've basically bounced this to and from an FTP server all the way over to a TNFS server with an Atari in the middle, basically handling the transfer. Now, currently the Atari is in the middle reading those bytes and funneling them back out. But there will be an optimization to take and cut that out of the process and have that entirely happen on the FSP itself. This will speed things up even more. So, I mean, with that, I guess I'll also basically end and say that InCopy works with any end device that you actually actively have, that you actively have something that you can basically talk to. So for this next bit, I'll actually take and change the NCD entirely here. And we will go to an HTTPS server. And I copied a file over here ahead of time. It's sitting on my web server, and we'll take and copy it over. Oops. Apologies. Let me go back and load InCopy. And we will go from in. We will copy that from here to here. Now recall that I set the prefix to an HTTPS site. This essentially means that we're doing the transfer over SSL, TLS, encrypted, coming across, and the ESP is handling the decryption itself. And there we go. And this is a really long beep because it's actually filling up that buffer hard as it can. And as a final bit, we'll actually take now, just as a final demonstration, I'm going to keep this as it is. And we're going to actually, going to reset. I have F reset on here. Yep. We are now going to take and boot into a different operating system. In this case, we're actually going to boot into DOS. Just to prove the point. And hopefully I made some changes to the code here. Hopefully this will work just fine. We shall see. This will serve me to improvise. I always say I won't improvise, and yet this is exactly what I do at some point in the demonstration. And yeah, kind of figured. I kind of figured this was going to happen, and it's literally because, yeah, high-speed code is kind of spamming by here. Let me make a slight change, go into PBI mode, go into high-speed mode. Yeah, high-speed code from here will take over and think. Come on. You can do it. Come on. Oh, you can do it. Did I accidentally... Yeah, I guess I must have accidentally messed up this disk. If so, no big deal. I will see if RealDOS will just to really get this across. So go here, boom. We will try this again. I guess I need to replace my Sparta-DOS disk, because I may have, in my process of developing this, munched things up a bit. Yep. Okay. I recall on drive 2 we have our ability here. Bam, there we go. InCopy, etc. The end device isn't over here. It doesn't know about the end device. But I can just as easily take and go. We'll actually take and go, for example. And you can see, because we're running it from the command line, it adapts appropriately, no problem. We can do an NPWD so we can kind of see what's going on. Well, see if I can do that again. Looks like, let's see if this actually will cause a problem. See what happens. And since I didn't specify anything at all, I'm going to just go. Happens. Yeah. Kind of figured. That's okay. That little bit of garbage on the end caused something not to happen, so that's okay. We'll try again. Okay. It looks like command line processing is a little off here. So let me just go ahead. And I'll do it from here. That's a nice reason that we have fallbacks, because sometimes command line processing can get a little sideways. Stuff, collections. Looks like it's just more bugs that I have to take and work. And again, if we go ahead, we can, I'll go ahead and just give a file spec here to look for all the basic files. I get it. I made a mistake. Okay. Well, this is definitely biting me in the butt. Let me see if let me try one more time. Try just here. Alright, so it basically looks like we've got just a little bit of command line processing happening here, so we'll go ahead. Buffers are not quite where they need to be. Stuff, collections. Try again, Holmes 2, Atari Archives. Files 88. Again, bam. Hit the brake to stop. Come on. You're not gonna let me, are you? Okay. So maybe look for all the basic files. And so on. So while the end device will allow you to take, for example, and load these files directly from your applications, like say from BASIC or Atari Writer and whatnot, that end device actually takes up resident memory space. So if you don't need it all the time, you don't need to run it, and you can use these utilities instead. So let's say, for example, we can do, for example, this. And it lay out, okay. Looks like I need to do a little bit of command line processing here. That's how it's supposed to work. Okay, never mind. I realized what I did wrong. Because file names can have spaces, we can't just do space here. But we can see right there, bam, 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 and so on. Let's see, delete window basic. And we'll do again. This time we will actually do an NCD finally. From our TLS location, and we shall again space, huh? Again, a long beep. And there we go. So, I mean, there we go. That's where things are right now. So I'm working through writing these individual utilities. There are a couple more that need to be written. For example, ndel, which will delete files, nlock and nunlock for locking and unlocking files, and nren for renaming files. So you can do FMS operations on the end device without needing to use the end. So until next time, you'll see more here, but I wanted to give you guys an update of what's happened in the last 11. Until next time, guys, have fun.